first one that we're going to look at. Basically, I guess I should say this. Basically, when we're doing volumes and anything else that we're going to do as far as applications of integrals, we're going to think in slices. So if we're trying to find the volume of a shape, we're going to think, okay, if I slice this, can I find the volume of the slice? And then if I can, I'll add up all the slices. So looking at this problem, we have the base that is circular. So this is a bird's eye view of this thing. The base is the circle. And then the cross sections, if you could slice, like we're looking bird's eye view, you could slice onto the board and pull out a slice. It tells us that the cross sections are squares. So if we could slice this and pull out a slice, we would get a square every time. Now if you look, I guess I should do this one here, so you can down here. If you look right here, this is the length of one of the sides. So the square is going to jut out that same length. Because all the sides have to be the same. Okay? If you look at a square here, it's not as long, so it's not going to be as tall. Do you see that? Do you have any idea what this thing looks like? It says in the yellow state. Find the volume if cross sections perpendicular to its diameter of circular base are squares. Okay, so first of all, just follow me through one problem. I promise. This will maybe make more sense. Okay, this is a shape. We actually don't know what the shape looks like because we're looking at bird's eye view and all we see is a circle. It's base. Okay? It's sticking out for you. So you can't see the shape. But what I do know about this shape is that the cross section, so if I were to slice into the circle and pull out the little slice, it's going to look like a square. So if it slides close to the middle here, it's going to be a really tall square because it's going to have to be the same length as the chord. Right? The chord of the circle here. The height has to be that same length because it's a square.
You're trying to pull out like up,
like 40
inside. So like if
this is where like bird's eye view.
And you're like
pulling it out, right?
So let's say it was
Hang on. Let's not change the scenario. So hang on. All right. So when you pull from here, the square is going to be larger. When you pull from here, the square is going to be shorter. Do you see that? Does anyone just see in their mind what this shape would look like? Some people have a guess. Some people can just like see the shape in their mind. I cannot ever. And I've been doing this a long time. And I'm going to show you this. Okay, so if we were to drop this flat, so we can kind of see what's going on. Here's our 4 different squares. So this is what I was telling you, that close to this middle right here, the squares are going to be taller. Close to the edge, they're going to be shorter. Make sense? Do you see the shape now?
Oh no.
So what we would do is we would find the volume of the slice and then add up all the slices. This is actually just the slice.
the pyramid.
Yes, actually. The drum is close to the middle, sorry.
No, you didn't. It's gonna go on.
Definitely not as no.
Yeah, that's a cool that.
This is running so. Okay, this is what the salt looks like. So if here, I don't know, it reminds me of spring roll or something. Should it spring roll? Okay, so anyway, now I just screen captured Grace there. Great. Okay, so here we are, right here. We have this shape. Here's the good news. We don't have to know what the shape is. We don't have to know what the shape is in order to solve the problem. Okay, that is good to know. So let's say that let's just use this actual picture as an example. And I gotta figure out how many to do this. Okay, we said this is a circular radius 2. Okay, we know that this was a circular base of radius and the cross sections were squares. So if let me find a blank sheet here. If I were to draw this, here's my circle. And I know that they're across the perpendicular x-axis are, so if I were to take this little slice and pull it and put it on its side, so if I were to like pull it out like this, and it over on its side, it would be a square like this, right? Okay. So I need to find the volume. I need to find the volume of this. Okay. I don't know how long this side is. It came from right here. Well, what is the equation of this part of the circle? Right? What is this equation of this part of the circle? Okay, so how long is this right? How long is this side? Two y, yeah. So 2 times the square root of 4 minus x squared. See, if you have to find the length, you would do top minus bottom. Root 4 minus x squared minus negative root 4 minus x squared would be 2 minus x squared. That's how you find the distance between things, right? Yes, you all did. Since this is a square, how long is that going to be? Okay, so if I find the volume of this little square, I'm saying volume because slice has to have a little bit of width. It's going to be 4 times 4 minus x squared times what? How long is this? How wide is it? The equation of a, yeah.
And why did the outside of that?
Because in order to define this in terms of y, you have to split it up into two different things.
So why is one
If you solve this for y, you're going to get plus or minus square root 4.
So are we just saying that's one root?
What do you mean?
The y value at the top and the bottom?
Excuse me. Alright, so we multiply the sides together to get the area of the square. Now how do we figure out how it is right here? Well, I'm trying to pick the small slice, right? So what's the length probably be? Dx. Some really infinitesimal change in x. This is the area. This is the volume of an arbitrary slice. If I pick any one of them, even if I were to draw it here, the same area, right? So if you added all the slices up, let's say from -2 to +2, would you get the volume of shape? Yeah, you would. Okay, I don't expect you to have mastered it yet. Give me one more example. I'm not going to worry about integrating this because I'm going to assume that you can integrate that without being a good assumption on what. Okay, look at another one. Let's look at okay, let's look at this one. Find the volume if the cross section is perpendicular to a leg of the right triangle or semicircle. So basically what's going to happen is we're looking bird's eye of a triangle and the slice is this way, perpendicular to one of the legs. Actually, I think sorry, I think it actually doesn't matter which way you draw. Okay, the semicircle is this way, or the cross section is this way, or semicircle. Okay. Well, see what this is going to look like.
I have an image. I know what it looks like.
Here's 5 of the semicircles.
I knew this one.
You did? What were you going to say?
Somehow I decided I knew it was
It's not a cone. It looks like a skewed cone. Like it's all skewed to one side. You see that?
Yeah, like it's
Right, exactly. Yes, good. If you move this, it probably would. Oh, I can't move it that way. Okay, so let's figure out how the song of this. They know their shapes. Alright, so go back to the original way this was. I don't remember. D was 4. Okay, so see this? We have 4 and 3, and the cross sections are semicircles. Let's go back to our D. Okay. So we have our axis. This was 4. This was 3. Here's my base. So if I take an arbitrary slice out of the middle and I get over here and like flip it up like this, right? Oh, sorry. It's just that. Hang on. So if I were to slice this right here and take it out and lay it like this, I would get this image. Okay, I'm going to find the volume of this slice. First I need the area. What's the area of a semicircle? Squared over 2. Okay, what is radius here? Well, it comes from this picture. The radius is going to be halfway to this line, right? What is this line? Okay, we need to find, so just think about what is the volume of a semicircle. Well, what's the semicircle? We get pi r squared over 2. What r, look at my thing, say, okay, well I know it's halfway to this line. So line is 3/4 x minus 3, the y-intercept is -3, the slope is up 3 over 4. Okay? So I get this line. It's going to be half of that. So it's going to be, the radius is going to be 3/8 x minus 3/2. It's not all the way, that would be the diameter. That's this one. Yes. Okay, no. These are the way it's sliced. So you're looking for the radius here. Yes. I'm going to finish the problem on the video, and then I will make sure that you're from whenever we were originally supposed to learn this. Yes. Okay, so the volume of the slice is going to be quiet while you're leaving. Hush while you're leaving. The volume of the slice is going to be pi times r squared over 2. And then to multiply by the width here, actually in this case this is going to be dy. So to go back and figure this out first. If this is going to be in terms of y, this was my original y, I need this to be x equals. So I have x equals y plus 3 times 4/3. And then if I divide that by 2, I would get 4/6 y plus 2. So I times r squared, which my r is 4/6 y plus 2 squared, dy, which is going to be my width of the slice. Then I'll integrate that from -3 to 0, since everything is in terms of y. You can do that on your calculator. Your homework for tonight is going to be 6.2, 55, 56, 7, and 58.